Assalamualaikum and hi everyone. My name is Wan Nazira Fazlin binti Muhammad Zaki. My matrix number is DG210027. My group member is Azizwan, Komin Chai, Wan Sidir Atel and Gurul Husna. Today we will present about Sladecrank. Today I will present about introduction. Firstly, dynamics is the discipline of physical science and a subset of mechanics that studies the motion of material objects in relation to the physical force that influence them. Force, mass, momentum, and energy. There are many things in our environment that make use of our understanding of dynamic calculation. We will able to understand the principle of rigid body mechanics and kinematics by understanding the broad course of dynamics. Next, the Sladecrank mechanism is a particular 4-bar linkage configuration that converts linear motion to rotational or vice versa. This mechanism is frequently seen in internal combustion engines, where the pressure produced by burning a cylinder drives a piston. Through the mutual link known as the connecting rod, the piston linear motion is transformed into rotation motion at the crank. Shaking force are generated and applied to the crank housing as the design of the crank drive the conversion of linear motion to rotational motion. In order to study machine kinematics and the consequent dynamic force, the Sladecrank mechanism is commonly used in undergraduate engineering course. Analytical calculation can be made to determine the position, velocity, acceleration, and shaking force produced during operation of a Sladecrank system. The angular velocity of a crankshaft is commonly assumed to be constant. In reality, the power stroke has a little higher angular velocity than the return stroke. For objective, firstly, to determine the linear displacement of the piston in the Sladecrank. Next, to find the linear velocity of piston in the Sladecrank system, and to find the linear acceleration of piston in the Sladecrank system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Sidir Atel bin Muhammad Zaki. Today I will talk about the case study of the dynamic mini project. So, for the case study, the traditional Sladecrank mechanism consists of a piston, cylinder, connecting rod, and crankshaft. In general, a Sladecrank converts motion produced by a working with linear displacement of a piston to rotating motion of a shaft. Engines are one of the most popular use for Sladecrank among many other use. The single piston pneumatic engine is one of the examples of the Sladecrank mechanism. The kinematic of the Sladecrank are clearly seen with this kind of engine. Compressed air or steam can be used to power the device, which is powered by pressure applied to the one side of the piston inside the cylinder. The next one, the methodology of the mini project. In order to calculate the linear displacement of the piston in the Sladecrank system, my group set up a Sladecrank system with a radius of OA is 250 mm and for the length of AB is 80 mm. These are the figure of the example for the Sladecrank mechanism. To find the linear displacement of the piston in the Sladecrank, the equation used is the S equals to R times to the 1 subtract to cos theta plus to n subtract to the square root of the n to the power of 2 subtract to the sine the power of 2 theta, where the S is the linear displacement of the piston. For the R is the radius of crankshaft and the N is the ratio of connecting rod to crank rod. For the linear velocity in the Sladecrank also can be calculated by using the equation of the V equals to RW times sin theta plus sin 2 theta divided by 2n, which is the V is the linear velocity of piston, R is the radius of crankshaft, the W is the angular velocity, for the N is the ratio of connecting rod to crank rod. In order to calculate the linear velocity of piston, the angular velocity on the connecting rod are required, and it can be calculated by using this equation, which is the W of AB equals to W times by the cos theta divided by the square root of n power of 2 minus sine power of 2 theta, which is the W of AB is the angular velocity on the connecting rod, and for the N is the ratio of connecting rod to crank rod. The linear acceleration for the crank system was calculated using the formula A equals to R W power of 2 times by the cos theta plus cos 2 theta divided by 2n, which is the A is the linear acceleration of piston, R is the radius of crankshaft, W is the angular velocity, and for the N is the ratio of connecting rod to crank rod. However, the linear acceleration of the connecting rod on the piston can be calculated using the formula of A of the AB equals to W power of 2 times by sine theta times to N the power of 2 minus 1 divided by the N the power of 2 minus sine the power of 2 theta in the bracket the power of 3 divided by 2, 3 over 2, which is the A of AB is the linear acceleration of connecting rod, for the W is the angular velocity, and last but not least the N is the ratio of connecting rod to crank rod. And that's all from me. Thank you very much.
Hi, my name is Andre with the number matrix of DD210016, and today I'm presenting about the calculations. So the figure shown is the setup of the slider crank mechanism. The provided information for doing this calculation are the length of the crank rod OA is 80 mm, while the connecting rod AB is 250 mm. It can also be called as 0.08 meters and 0.25 meters respectively. The angular velocity at OA is equals to 85 radian per second, and the theta is equals to 55 degree. The assumption of the analysis is made of the forces neglecting the weight and inertia effect of the crank rod OA and connecting rod AB. So moving on to the next slide. So, but before we start the calculations, we must first determine the ratio of the length of the connecting rod AB to the length of the crank rod OA. The ratio is known as N. The formula used is N equals to R2, which is the length of the connecting rod AB, over the R1, which is the length of the crank rod OA. So it will be equals to 0.25 over 0.08, and we'll get the ratio equals to 3.125. After obtaining the value of the N, now when the slider crank is moving, we know that the crank rod OA rotates in a clockwise direction as shown as the figure before. It will move the connecting rod AB as well, which leads to the moving of the piston or slider B from left to the right. That will be a displacement. So in order to find the linear displacement of the piston, the formula is used, which is the displacement x equals to the R1, which is the length of the crank rod OA, which is 0.08 meter, to the bracket of 1 minus cos theta bracket plus bracket of n minus square root of n square minus sine square theta bracket. By substituting the known value of the angle theta, which is 55 degree, and the length of the crank rod R1, which is 0.08, and the value of the n, which is 3.125 into the formula, we can find that the x will be equals to 0.0429, which is the linear displacement of the pistons. So for the linear velocity of the piston, we will determine by using the formula V equals to R1 times the angular velocity, which is the 85 radian per second, times to the bracket of sine theta plus sine 2 theta over 2 and bracket. By substituting the value of the angular velocity, the value of the theta, the length of the crank rod, and the value of the n, we will get that the linear velocity of the piston equals to 6.5929 meter per second. While the linear acceleration of the piston can be determined by using the formula acceleration A equals to the length of the crank rod times by the angular velocity power 2 times the bracket of cos theta plus cos 2 theta over 2n bracket. After substituting the known values, we will get that the linear acceleration of the piston equals to 299.8972 meter per second square. After the linear displacement velocity and acceleration of the piston has been calculated, now we will determine the angular velocity of connecting rod AB. The following equation is used, which is the angular velocity of connecting rod AB equals to the angular velocity provided at OA, which is 85 radian per second, times by the cos theta over square root of sine n2 minus sine 2 sine square theta. It is determined that the angular velocity of the connecting rod AB will be 16.1666 radian per second after substituting the values and complete the equation. Then the angular acceleration of the connecting rod AB will be calculated by using the formula acceleration of the connecting rod AB equals to the angular velocity square times by the sine theta bracket n square minus 1 over the bracket of n square minus sine square theta bracket to the power of 3 over 2. Hence, it is determined that the angular acceleration of the connecting rod AB will be 1891.5106 radian per second square. Moving on to the analysis evaluation. So, the linear displacement of the piston means that the term displacement first stands for the direct distance for something that moves from the original position to the new position, while the term linear means a straight line. Therefore, the linear displacement of piston can be defined as the moving distance of the piston along a single axis in straight line. The unit for displacement is measured in m, which is a meter. The linear velocity of the piston, for the term velocity stands for the rate change of displacement, so it is the movement speed of the piston along a single axis in a straight line. The unit for velocity is measured in meters per second and represented by the letter v. And for the linear acceleration of the piston, the term acceleration stands for the rate change of velocity. Therefore, it is the rate change of movement speed of the piston along a single axis in a straight line. The unit for acceleration is measured in meter per second square and represented by the letter a, which stands for acceleration. And for the angular velocity of the connecting rod, the angular velocity is the rate change of angular position of a rotating body. It is the movement speed of the connecting rod rotates and revolves about an axis. The unit for angular velocity is measured in radian per second and represented by the Greek letter omega. So for the last one, which is the angular acceleration of the connecting rod, the angular acceleration is the rate change of angular velocity. So the unit for angular acceleration is measured in radian per second square and represented by the letter alpha a. So that's all for me. Now I'll pass my time to the next presenter. Thank you.
Hello, my name is Komi Chai with the matrix number of DD210014. So I'm going to present about the discussions. So discussions will do based on 3 parts. The first one is based on the calculations, the second one is based on the evaluation, and the third one will be based on the case study. So the first one, based on the calculations, the ratio of the length of connecting rod and crank rod, linear displacements of piston, linear velocity of piston, linear acceleration of piston, angular velocity of connecting rod AB, angular acceleration of connecting rod AB are identified. Hence, the element of motion of rotation of the crankshaft is demonstrated. The calculations show that the crankshaft gets motion by the connecting rod. It transforms the reciprocating motion into rotary motion and rotates the flywheel. Thus, we can deduce that a reciprocating engine is unable to deliver the reciprocating of a piston to the drive shaft without a crane. This shows that the piston must be working together with the crankshaft in order to perform its function. So move on to the next slide. From the analysis and evaluation of the crankshaft mechanism, we know that both 2-stroke and 4-strokes engines have this shaft and it is installed inside the cylinder. We also identified that a crankshaft gets motion by piston through a connecting rod and it transforms the piston's reciprocating movement into a rotary motion. We also identified that the piston rotates through a connecting rod and has a high weight. In this case study, we also know about that the crankshaft rotates 2 times to complete a power cycle. So move on to the next slide. Based on the case study, we have an understanding of conceptually based mathematics and information science to support the analysis. The motion of the crankshaft is also demonstrated, observed, and analyzed. The recommendation for this study is use crankshaft of different sizes or different material to show the effects of the sizes or materials to the function of crankshaft and make a comparison to show the ranking of the sizes or materials. This will deepen the knowledge and understanding of the crankshaft mechanism. So this is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurusna Yuzana Abidin. Now I would like to talk about the conclusion. Based on the case study that we conducted, we can observe that the proper implementation of both theoretical knowledge and formulas related that we learn will further improve our understanding about this situation in real life. According to the calculation that we analyzed, we can obtain the values of the linear displacement, velocity, and acceleration of the slided crank. From the result obtained, it can be observed that the pattern of the angular velocity is constant. The characteristic of the mechanism of the small and simple part is learned since it is going to be used in the complex and complicated motions applications such as foot pump and engine. By generating the examples and theoretical situation, we can relate this with the characteristic of the mechanism of the small and simple part is learned since it is going to be used in a complex and complicated motion application such as foot pump and engine. By generating the examples and theoretical situation, we can relate the question with our current situation, thus making it easier to familiarize with the problems. The better utilization of the formulas can reduce the load of having to make redundant calculation, and at the same time, it will help us to enhance knowledge regarding to the related topic. For the recommendation, we are advised to inspect all of the apparatus involved in the investigation beforehand in case we are creating a real-life situation using any tool to make sure it can function well and giving the accurate result. Besides that, we also can make a comparison by taking 3 different values based on the result of calculation that has been made. The different values can be used to calculate the average value. It could help us to avoid any error for the values that will be recorded in the data and used in the computation. Therefore, we may see the differences of the values obtained for each readings. That's all from us. Thank you.